Hi guys, we're going to take a look at the last few problems from our review. So we are on page 35 down towards the bottom. Okay. Remember you got to skip problems 30 through 34. So we are down at the very bottom of page 35. We're taking a look at features we can pick out from a function to describe our graph. So as I take a look at number 35, we're given the function here. One of the easy things to pick out would be the degree. So I'm going to go ahead and start there. So my degree when I have factored form means I add up those exponents. So 4 plus 2 would give me 6. My degree is 6. And then the sign of my leading coefficient is also easy to pick out here. My lead coefficient is -2. So that sign is negative. My lead coefficient is negative. Remember, when we have even degree, our ends go the same direction. When that lead coefficient is negative, that means both ends will go down. So I can also fill in my end behavior here. On the left side of our graph, my end will go down. So I'm going to say y goes to -infinity. On the right side of my graph, same thing. That end's going down, so y approaches -infinity. From here, I'm going to pick out my x-intercepts. I have factored form, so it's easy to see my x-intercepts from there. So from my first factor, I have an x-intercept of +3. Its multiplicity is the exponent, so its multiplicity is 4, and then its behavior. Remember, for behavior, we're looking at linear, quadratic, or cubic. I'm asking for its behavior at the x-axis. Linear means a multiplicity of 1, quadratic means a multiplicity that's an even number, and cubic means a multiplicity that's an odd number that's greater than 1. Since I have an even number here, that means this is going to have quadratic behavior. My other factor, x plus 2, will give me an x-intercept at -2. Its exponent is 2, that means its multiplicity is 2. And again, since its multiplicity is even, we'd have quadratic behavior here. The final thing I'm asking you for is the y-intercept. The y-intercept happens when x is 0, so I can find the y-intercept by plugging in 0 for x. So that would be -2 times 0 minus 3 to the 4th times 0 plus 2 squared. You may need a calculator to help you simplify this, but that's okay. So this would be -2 times 81 times 4. That would give us -648. So our y-intercept here would be -648. Number 36, same idea. My lead coefficient is -0.5. So the sign of my lead coefficient is negative. My degree would be 1 plus 3 plus 1, so that's 5. Odd degree polynomials, the ends go in opposite directions. Odds go opposite. Since my lead coefficient is negative, I'm going to have a general trend down from left to right. That means on the left end, my arrow is pointing up, so y approaches infinity. On the right end, my arrow is pointing down, so y approaches -infinity. Now let's take a look at our multiplicities. So here's x, here's my first factor of x. So I have an x-intercept at 0. Its multiplicity is 1. So that means it's going to have linear behavior. My next factor with an x is x minus 2. That means I have an x-intercept at +2. Its multiplicity is 3. 3 is an odd number bigger than 1, so this will be cubic behavior. And then finally, x minus 5 means I have an x-intercept at +5. Its multiplicity is a 1, since its exponent is 1, and a multiplicity of 1 means I've got linear behavior. Finally, we're going to take a look at the y-intercept for this problem, and I'm going to find it the same way I did for number 35. I'm going to plug in 0 anywhere I see an x. So this would be -0.5 times 0 times 0 minus 2 to the 3rd power times 0 minus 5. So I want you to notice here, I would get 0 times 0.5 here is just 0. And then 0 times -2 cubed, still going to be 0. And then 0 times -5, still going to be 0. So I have a y-intercept of 0 on this one. And then finally, number 37, they didn't give us the function for number 37. We're going to write it based on the information that they did give us. So they gave us a degree, they gave us a part of our end behavior. So let's start here. I know my degree is even, and on the left end, our arrow goes up. Since even degree functions have ends that go in the same direction, that means this end also has to go up. So on the right end, y is also going to approach infinity. And since both ends go up, that means our lead coefficient had to be positive. Now let's take a look at our x-intercepts and the multiplicities that we know. So I can see that for an x-intercept of 2, I have linear behavior. Linear means it has to have a multiplicity of 1. Now, if I look at the multiplicities I know so far, multiplicity of 2 and a multiplicity of 1, so far I've got 3. I should have a total, if I add all my multiplicities together, that would be like adding up all my exponents. So I should get a total of 6. That means I've got 3 left over. It says that this first x-intercept is going to have cubic behavior. Multiplicity of 3 would give me cubic behavior, so that checks out. And then finally, I don't have the behavior for this last one. The multiplicity is 2. Since that's an even number, I would have quadratic behavior. So now I can go ahead and write my function. So I would have y equals x plus 1 to the third power times x minus 2 to the first power. You can write that 1 or not. And then x minus 3 to the second power. I'm going to assume that my lead coefficient is 1 here because they haven't given any other information. If they had given me the y-intercept, I could see for sure if it was 1 or not. But since they haven't, I'm just going to assume 1 and use that to find my y-intercept. To find my y-intercept, I'm going to plug in 0 for all my x's. And again, if you need a calculator to simplify here, that's fine. We would end up with 1 times negative 2 times 9, which would be negative 18. So my y-intercept there is negative 18. And that's all your review problems. Make sure you ask questions in class or before or after school if you got stuck on any of these. If you got something different than what you're seeing here, please ask your teacher so that we can make sure that you are on the right track for your quiz.